All right, fantastic. Well, our last presentation for this session is focused on the iGuide climbers, developing a model for multidisciplinary academic labs for early career development. So I think we have, multiple. Okay, so two, wonderful. So Nick and Adam are going to be up here, and I will pass the microphone to them.
Hi everyone, I'm Adam. This is Nick. We're both part of the climbers group within iGuide. So thank you everyone for taking the time to learn a little bit about our group. So our group is one which we hope could potentially serve as a model for interdisciplinary collaboration for early career academics. This presentation was a collaborative effort between multiple members of the climbers group, and that includes Iman, Wei, Ramya, Pin-Ching, Nick, Alex, Ayman, Jinwoo, Jimin, myself, and Jianan. So yeah, it's not just me and Nick who worked on these slides. I want to give a special mention as well to Iman, who put in a particularly substantial amount of time towards getting everyone together to make this presentation possible, and also the paper associated with it as well. So a quick overview, who are we? We're early career academics who are all part of iGuide, but associated with various different universities across the US. We use geospatial models to address interdisciplinary problems, and these are problems that we hope would potentially have a high impact upon society. Our goal when we meet is not necessarily to work directly on research, but rather to foster an environment that's conducive to future collaborative efforts between different disciplines. We think that this is needed because more conventional approaches towards these sorts of meetings and academic collaboration might forego valuable interdisciplinary opportunities, especially between researchers working in fields that might not appear closely related to each other. So some of the potential benefits of our group format versus others include the fact that our group is self-administered. So the members of our group need to employ organizing skills that are going to be necessary later on in a career within academia. And the group also provides highly accessible and welcoming avenues for sharing research, as well as gaining feedback, critique, and advice from other perspectives. And these perspectives include those from peers with differing levels of experience too, since our group includes graduate students, postdocs, as well as research scientists. So these collaborative efforts can take place through multiple different avenues, including things such as group brainstorming. And again, the idea is to foster a low-stakes discussion environment where potential collaborations for novel approaches to interesting and impactful problems can grow organically. So some things that we do within our group include regular meetings and presentations over Zoom. And we also do some in-person activities as well, when that is possible, for example, at iGuide meetings or at AGU. And the great majority of our activities are self-organized, so also doing things such as fairly allocating the workload for administrative action items is important. And we try to employ quite basic collaboration tools as best as we can. In addition, our members come from diverse backgrounds in regard to aspects such as academic discipline, gender, ethnicity. So this is great for advancing research, where we can employ different perspectives, and I think especially within the social sciences, but we do also need to take care to foster and maintain an appropriate culture of respect and inclusion. Some of the examples of multiple collaborations that we've seen between climbers include the Geospatial Knowledge Hypercube, and that uses natural language processing to automatically extract information about aging dams from online sources. Another project involves applying cyber infrastructure tools to convergent sciences, and this includes the provision of compute tools for computationally intensive problems in the social sciences, or in the geospatial sciences. A further ongoing collaboration also involves more application of machine learning models, namely more advanced ones, including NLP ones like GPT, and that's for event and event relation extraction. Some of the challenges that we've met within our group, there's quite a few, but first, there has to be a trade-off between in-depth knowledge sharing and also maintaining the interest and participation of those with less expertise in the topic that's being discussed. In addition, we also have to provide the right level of structure to our meetings and activities in such a way that balances the interests of sometimes conflicting aims of our group. Finally, another example of one of the challenges is the difficulties in evaluating the success of our group, because the outcomes and goals are sometimes intangible, though we have had more tangible measures of success, such as collaborating on a conference paper for this forum, or namely this presentation. And we're also trying to develop this further into a paper that we're trying to submit to a academic journal too. And we've also been subject to external evaluation of our group. So now I'm going to hand over to Nick, who's going to talk a bit more about, in more detail, about the examples of collaborative projects that we've seen emerge from our group. And the topics include aging dams, flooding risks, and so on.
All right. Thank you, Adam. So yeah, I'm just going to go through some of the examples through different sort of like subgroups within the climbers group. I think that it's useful to kind of have different people working towards different goals, and you can't have however many people we have in our climbers group all working on every single project. So and each of us have different backgrounds and expertises, so naturally these sort of subgroups will emerge, and I think that rolling with that is a good idea, and trying to continue with these natural collaborations is actually really helpful and has led to some interesting progress. So for example, speaking from a personal level, coming into my project, I knew that there was the telecoupled soybean trade, and that was something that I was interested in pursuing, but I do not have an economics background, and that, as the last presentation says, economics plays a huge role in geography, I come to learn. And working with Iman on this front has been super helpful to be able to take these economic principles and apply them then to the telecoupling framework. So initially it was just regressions, a set of regressions trying to figure out the correlations between these, but with Simple G we were able to sort of extend that a little bit. And it's made that work a lot more robust, realistic, and overall just better from the collaborations with the climbers on that front. Also, several projects focused on aging dams and flooding specifically. So Jinwoo led a vulnerability analysis on flood risks per major river basins, which you can see in the top, and I think that was discussed a little bit earlier as well. Adam and Jungwoo focused on examining precipitation and isolation in the top corner there, that showed that when you examine these trends in isolation, it might not be realistic, so you can look at the 30-day preceding precipitation in tandem with this and get a more statistically realistic picture. Also, Jimeng is using deep learning for improved flood prediction and mitigation through the automatic control of hydrologic features, such as gates and pumps. And Mohammed, who I don't think is here today, but he led machine learning models to predict storm surge in coastal systems. So this is sort of the second subgroup, is aging dam failures and floodings. And also the climbers have been leveraging state-of-the-art artificial intelligence, large language models, and cyber infrastructure to facilitate these collaborations. So for example, they have designed a new data architecture called the Hypercube, which you can see in the middle there, which has been integrated with the Aging Dam project from sort of the last slide. They also have been working on developing a new cyber infrastructure tool called CyberGIS Compute to make accessing high-performance computing for hydrologists that might have technical barriers. There's also been tools to better understand the impact of iGuide working groups, so that one of them is the Geospatial Ethics Checklist, which will help our climbers to understand some of the ethical principles associated with their practices. And lastly, I want to touch on the logic model that was developed by our evaluation and knowledge transfer team, which is sort of in the middle there. And this tool can be leveraged by climbers to understand the group outcomes as a whole and also consider the ethical practices that are being looked at within the iGuide ecosystem. And lastly, I want to go through some of these individual slides to look at each of our individual climbers members, mostly for the sake of the recording. I'm not going to read into every single word on these next slides, but I want to show some of the work that these individuals have been doing that contributes to these larger groups. So first, Iman Haqiqi, working with Simple G. He's talked a lot about, he's kind of been one of the major contributors for our group and has been a big leader in getting everyone together and pushing these collaborations. I've also worked with Iman to develop some of these different ideas. Jin Woo was a climber but has since graduated and found a faculty position, but he also was very instrumental in getting this group up and running and worked a lot on the vulnerability of aging dams, aging dam theory, really invested in the success of the climbers group. Jung Woo also was very collaborative in his approaches to aging dams and statistically significant trends in climate signals, along with Adam, who worked mostly with Jung Woo in developing the assessment of flood risk and compound extremes. Mohammed Ahmadi worked with storm surge surrogate modeling using machine learning on I think here's the coast of Texas. Jimeng Shi, as I mentioned earlier, worked with deep learning models for flood predictions and mitigation and is coordinating within that aging dams group. Jiaonan Wang was instrumental in the Aging Dams Hypercube and bringing the Hypercube and Aging Dam projects together for geospatial discovery. Wei Hu, who is working on applying AI techniques to convergent topics. So working on bringing this Hypercube idea to the telecoupling framework and discovering how these disasters might be discoverable through geospatial text. Alex Michels, who has a nice GIF here in his slide, showed work on CyberGIS compute and simplifying access to high-performance computing. Ramya Kumaran was really our representative from the evaluation knowledge transfer team, and she has developed this plan that you can see here, the logic model, in evaluating performance of the iGuide climbers. And also Yvonne Kong, working with ethics in geospatial data science, developing the geospatial checklist, and Ayman, who is working with large-scale hydrologic modeling and the national water model. So thank you all for your time today, and we would be open to any sort of questions, comments, feedback, or hearing some of the other approaches that you have had experience with collaborating with early career faculty, among early career faculty, because this is really a learning experience. And feel free to, if you recognize any of the names on the name tags that Adam listed earlier, if you see someone who is a member of the climbers team, grab them and just, give us some feedback and some ideas on working together as a collaborative group. Thank you.